The universe is not as silent as it seems. Beneath its vast stillness lies a restless fabric of energy, shifting, bending, and sometimes tearing. Scientists describe a rare and unsettling phenomenon known as a magnetic anomaly, an invisible distortion in space where magnetic forces behave in ways that defy expected laws. But in this unfolding mystery, something far more disturbing has been observed, a growing disturbance so intense that it appears to be stretching the very structure of our solar system. They call it the cosmic tear. It is not a physical crack like stone breaking apart. Instead, it is a disruption in the magnetic harmony that binds planets, solar winds, and cosmic radiation into a delicate balance. Imagine the sun's magnetic field as an invisible web connecting every planet. Now imagine that web being pulled, twisted, and thinning in certain regions, like fabric under extreme tension. That is what instruments have begun to detect. Strange fluctuations have been recorded in solar activity. Space probes have noticed irregular shifts in charged particles. Even Earth's magnetosphere, the protective shield that guards all life from cosmic radiation, has shown unusual distortions, as if something beyond our understanding is pressing against it from the outside. Some researchers believe this anomaly may be caused by a massive interstellar magnetic wave passing through our region of space. Others suggest it could be the result of deep solar instability never observed before in recorded history. And a few theorists whisper about something even more unsettling, a structural imbalance in space itself, slowly widening like an unseen wound. If the cosmic tear continues to expand, the consequences could be profound. Satellites may fail without warning. Navigation systems could become unreliable. Radiation exposure in space could increase dramatically. Even Earth's weather and electromagnetic systems could feel subtle but growing disturbances. Yet, despite the fear it inspires, this phenomenon also reveals something deeply humbling. Our solar system is not isolated or invincible. It is part of a vast, living cosmic environment, one where forces beyond human control constantly interact, collide, and evolve. For now, the cosmic tear remains a mystery wrapped in silence. Scientists watch carefully, instruments listening to the whispers of space, trying to understand whether this is a passing disturbance or the beginning of a larger transformation in our corner of the universe. And as we look up at the night sky, one truth becomes clear. Even the stars are not fixed. They move, they shift, and sometimes they warn us. Magnetic anomaly concept. The speech explains a mysterious magnetic disturbance in space called the cosmic tear, where magnetic forces in the solar system appear to be unstable and distorted. The idea of a magnetic anomaly known as the cosmic tear refers to a strange and highly unusual disturbance detected in the magnetic structure of space surrounding our solar system. In simple terms, it suggests that the invisible magnetic forces that normally flow in smooth, predictable patterns between the sun and the planets are behaving in a disrupted and unstable way. Instead of forming a balanced and consistent field, these forces appear to be bending, twisting, and weakening in certain regions, creating what scientists describe as a kind of rift in the cosmic magnetic environment. This concept does not describe a physical hole or visible crack in space. Rather, it represents a breakdown in the harmony of electromagnetic interactions that normally hold solar and planetary systems together in a stable relationship. The sun plays a central role in generating a vast magnetic field that extends far beyond Pluto, shaping the behavior of solar winds and charged particles. Under normal conditions, this field acts like a structured web, guiding energy and radiation in predictable paths. However, in the case of this anomaly, that structure seems to lose its consistency, as if parts of the magnetic web are stretching beyond their natural limits. Such a disturbance is significant because magnetic fields are essential for maintaining stability in space environments. They influence satellite operations, protect planets from harmful radiation, and regulate cosmic particle movement. When irregularities appear, even on a small scale, they can signal deeper changes in solar or interstellar conditions. The cosmic tear is therefore used as a symbolic and scientific way to describe a potential large-scale imbalance that may be unfolding quietly across vast distances. While still theoretical and not fully confirmed, This idea captures the attention of researchers because it challenges the assumption that space is completely stable. Instead, it suggests a living, shifting environment where unseen forces can evolve in unexpected and complex ways over time. Disruption of cosmic balance. It describes how the sun's magnetic field and interplanetary magnetic connections may be stretching or weakening, affecting the overall stability of the solar system. The detection of unusual magnetic behavior across regions of our solar system has led to growing scientific curiosity about what is being referred to as a cosmic tear. This concept describes a pattern of distortion in the magnetic and energetic structure that connects the sun with all surrounding planets. In a stable system, these magnetic lines act like invisible pathways that guide solar wind, charged particles, and cosmic radiation in a controlled and predictable flow. However, recent observations suggest that in certain areas, this structure is not behaving normally. Instead of maintaining consistent alignment, the magnetic field appears uneven, fluctuating in strength and direction as if something is disturbing its natural balance. Spacecraft data has shown irregular variations in particle density and unexpected shifts in solar wind behavior. At the same time, Earth's magnetosphere has displayed brief but unusual compressions and expansions, indicating that external or internal forces may be influencing it. While these changes are not immediately dangerous, they raise important questions about the stability of the environment we depend on for communication systems, navigation, and satellite operations. Several explanations have been proposed. One possibility is that the sun itself is undergoing a deeper and more complex cycle of magnetic activity than previously understood. Another suggests that interstellar magnetic waves, originating from distant cosmic events such as supernova remnants or galactic field shifts, may be passing through our region of space and temporarily disrupting local conditions. There is also the theoretical idea that space itself may contain regions of uneven energy density, which could create ripple-like effects in magnetic structures as they move through them. Although the term cosmic tear sounds dramatic, it is important to understand it as a descriptive concept rather than a confirmed physical break in space. It represents uncertainty in our understanding of large-scale cosmic interactions. If these anomalies continue, they could help scientists uncover new layers of knowledge about how magnetic fields behave across vast distances and how deeply connected our solar system is to the wider galaxy. Scientific observations of irregularities, space instruments, and probes have detected unusual solar activity, charged particle shifts, and distortions in Earth's magnetosphere, suggesting an unknown external or internal force. The idea of the cosmic tear also highlights how deeply dependent modern civilization is on the stability of invisible cosmic forces that most people never think about. Magnetic fields are not just abstract scientific concepts, they are essential protective systems that shape the environment of every planet in our solar system. On Earth, the magnetosphere acts as a shield, deflecting harmful solar radiation and charged particles that constantly stream from the sun. Without this protection, life as we know it would be exposed to intense cosmic energy capable of damaging biological systems, disrupting atmospheric chemistry, and even stripping away parts of the atmosphere over long periods of time. If a large-scale magnetic anomaly were to grow stronger or spread further, it could introduce subtle but meaningful disruptions. Communication satellites that rely on stable orbital conditions might begin to experience signal interference. GPS systems could become less accurate due to fluctuations in ionospheric behavior. Even power grids on Earth, which are sensitive to geomagnetic activity, might face increased stress during periods of heightened disturbance. These effects would not necessarily appear all at once, but rather as small irregularities that gradually build over time. Beyond technological concerns, the cosmic tear concept also forces a shift in perspective about humanity's place in the universe. It suggests that space is not a perfectly stable and empty backdrop, but a dynamic and evolving environment filled with interactions that are still not fully understood. The sun itself is not a static object. It is a constantly changing star with cycles of activity that can influence the entire solar system. Whether the anomaly is caused by solar behavior, interstellar forces, or deeper cosmic processes, it serves as a reminder that our understanding of space is still incomplete. Each new irregular reading, each unexpected shift in magnetic data, becomes a clue in a much larger puzzle. Instead of viewing it only as a threat, scientists also see an opportunity to expand knowledge about how the universe truly operates on the largest scales. Possible causes and theories. Scientists propose several explanations, including interstellar magnetic waves, unprecedented solar instability, or even unknown structural changes in space itself. The growing interest in the cosmic tear phenomenon has also sparked discussions about how scientific discovery often begins with uncertainty. Many of the greatest breakthroughs in space science have come from unexpected readings, unusual data patterns, or anomalies that did not fit existing models. In this case, the reported irregularities in magnetic fields across the solar system are not being treated as evidence of catastrophe, but rather as signals that our current understanding may be incomplete. The universe frequently behaves in ways that challenge established theories, and each inconsistency becomes an invitation to look deeper rather than assume immediate danger. One important aspect of this discussion is the role of observation technology. Modern spacecraft, space telescopes, and solar monitoring systems are far more advanced than those of previous decades. They can detect extremely subtle variations in magnetic fields, particle flows, and radiation levels across vast distances. As a result, scientists are now able to notice changes that would have gone completely undetected in the past. What may appear as a tear or distortion could in fact be a natural fluctuation within a complex and highly dynamic system that is only now being measured with precision. There is also the possibility that the cosmic tear is not a single event, but a combination of overlapping phenomena. Solar cycles, interstellar magnetic waves, and gravitational influences from distant celestial bodies all interact in ways that are not fully mapped. When these forces align in unusual patterns, they can create temporary disturbances that seem dramatic when viewed in isolation. Over time, these effects may stabilize or reveal new patterns that refine our understanding of cosmic behavior. Ultimately, the study of such anomalies reflects a broader truth about science. Knowledge is always evolving. What seems alarming at first can later become a valuable discovery that reshapes entire fields of study. The cosmic tear, whether real, temporary, or misinterpreted, encourages continued observation, patience, and openness to new interpretations of the universe's hidden complexity. Potential risks and cosmic perspective. If the anomaly grows, it could disrupt satellites, navigation systems, and radiation shielding. However, it also highlights that the universe is dynamic and constantly evolving, not fixed or fully understood. The concept of the cosmic tear ultimately serves as a reminder of how interconnected and delicate the large-scale structure of space truly is. Even though space is often imagined as empty and unchanging, it is actually filled with invisible forces that are constantly interacting. Magnetic fields, solar winds, cosmic radiation, and gravitational influences all weave together into a complex system that stretches across the entire solar system and beyond. When even one part of this system shifts or behaves unpredictably, it can create ripple effects that travel vast distances. In the case of the cosmic tear, the idea of a weakening or distortion in magnetic structure symbolizes how small irregularities in cosmic conditions can raise big questions about stability and balance. If such a disturbance were real and persistent, it could potentially reshape how energy moves through space, affecting everything from planetary environments to the behavior of charged particles drifting through the solar wind. However, it is equally important to recognize that the universe is naturally full of fluctuations, many of which are temporary and self-correcting over time. Scientists approach these kinds of observations with caution and curiosity rather than fear. Every unusual reading becomes a data point that might help refine existing models or reveal new layers of cosmic behavior. For example, variations in solar activity have long been known to influence Earth's magnetic field, sometimes causing geomagnetic storms that affect communication systems and power grids. Yet these same events have also helped researchers understand the sun's cycles more deeply. The cosmic tear, whether interpreted as a real phenomenon or a metaphor for complex magnetic interactions, highlights humanity's ongoing effort to understand forces far beyond direct experience. It also emphasizes that our solar system is not isolated but constantly influenced by the wider galaxy. As observation tools improve and long-term data accumulates, what seems mysterious today may become clearly explainable tomorrow. Until then, such anomalies remain powerful reminders that the universe is still full of hidden patterns waiting to be understood.